Hello students, this is Callie Daniels, and in this video we will consider ratio, proportion, and percent. Well, a ratio is a comparison of two quantities using a quotient. Now, there are three ways that we can express a ratio. We might say that the ratio of dogs to cats on the Daniels farm is 2 to 4 and express this in words. We may also use the colon to express a ratio 2 to 4, but most conveniently we would use a quotient or a fraction to express a ratio and write this as 2 to 4. Now, if we do express it as a fraction, then we can reduce that fraction. 2/4 reduces to 1/2 if we divide the common factor of 2 out of both the numerator and denominator. Well, a proportion is a statement that two ratios are equal. And that's exactly what we have in this statement when we say 2 is to 4 as 1 is to 2. So here we've got a statement that these two fractions or ratios are indeed equal in value. Now in example 1, we're going to find the unit price for each brand of liquid detergent. So we've got three different purchasing options: 75 ounces at $8.94, 100 ounces at $13.97, and 150 ounces for a purchase price of $19.97. Now we want to find the price per ounce, and when we say price per ounce, that tells us the actual order in which we're going to divide to find the unit price. So for this first option, we're going to take that price, $8.94, and we're going to divide that by 75 ounces. Okay, and it's okay to go ahead and use your basic calculator here, and I'm going to do that. 894 divided by 75, and see if you get a 0.1192. And that's in dollars per ounces. But when we talk about a dollar amount, 0.1192, which I'm going to round to the nearest hundredth, as $0.12 per ounce. Well, if we convert this to cents, which I'm also going to do, $0.12, as we move that decimal point 2 places, that's approximately 12 cents per ounce. Now if we do likewise with our other purchase options and divide $13.97 by 100 ounces, I don't need my calculator for this. As we divide by 100, it's going to move the decimal point 2 places. So that is equal to $0.1397 per ounce. And if we round that to the nearest cent, okay, 0.14, or right about 14 cents per ounce. And lastly, if we divide 1997 by 150 ounces, then we're going to get approximately, and you can go ahead and do that, $0.1331 per ounce. Or moving that decimal point 2 places, rounding to the nearest hundred, that's about 13 cents per ounce. So if we're asked what our best buy is, we would definitely go for that first option, and purchase the 75-ounce bottle for 12 cents an ounce. Now in example 2, we're going to decide whether each proportion is true. Now above we looked at the proportion 2 is to 4 as 1 is to 2, or 2/4 equals 1/2. One way to determine if a proportion is a true statement is by looking at its cross products. For example, 2 times 2 is equal to 4 times 1. In other words, 4 is equal to 4. Okay, that is a true proportion because its cross products are equal. Now, as we look down here in example 2 part A, this is not going to be a true statement because 1/3 is not equivalent to 33/100. It's really close, but not exact. If we look at also the cross products, 3 times 33, is that equal to 1 times 100? No, that's not true. 99 is not equal to 100, so this is a false statement. I have a feeling that our next one is going to be a true statement. And just looking at that, we can tell it's a true statement because these are equivalent fractions. If we multiply 4 by 4, we get 16. And if we multiply 13 by 4 also, we get 52. So we can build up 4/13 to write 16 over 52. Or you might look at the right-hand fraction, the 16 over 52, and say, I can reduce that to 4/13. Okay? But let's also go ahead and check our cross products. Go ahead and multiply 13 times 16. And let's see if that is equal to 4 times 52. And in both cases, I believe you're going to see the value 208. Okay, that is a true statement, and this proportion is true as well. So proportion is a true statement, the cross products are equal. And we're going to use that fact as we solve proportions. In part A, we're going to determine what this numerator is. Okay, some value x is to 4 as 12 is to 30. Okay, if this is true, then the cross products are equal. So let's look at those. Let's multiply x times 30, or go ahead and write 30 times x with your coefficient in front. And let's multiply 4 times 12. Well, 4 times 12 is 48. Now we've got a linear equation to solve, and we're going to isolate x by dividing each side by 30. So x is equal to 48 over 30. Now we know this is going to reduce because those are both even numbers. So as you begin reducing, you might say, well, 48 is 2 times 24, and 30 is 2 times 15. And we can divide out that common factor of 2 and reduce this to 24/15. But 24/15 is also going to reduce because those each have a common factor of 5. Excuse me, 3. 24 is 3 times 8, and 15 is 3 times 5. So we can also divide out that common factor of 3 and write this answer as 8/5. It's okay to leave your answer in this improper form, larger number 8 over 5. But just make sure that you do reduce these. And you might look back at this and say, well, we could have reduced that a lot faster if we would have written 48 as 6 times 8 and 30 as 6 times 5. Okay, maybe you reduced it by dividing out that largest common factor of 6, okay, to arrive at the 8/5. And that would be really good. Okay. In part B, if this is a true proportion, then the cross products are equal. Let's look at those. Multiply 4 times 3r minus 9. Set that equal to 3 times 2r plus 8. Let's go ahead and distribute the 4 to give 12r minus 36. And distribute the 3 to obtain 6r plus 24. And this is a linear equation for us to solve. Okay. I'm going to subtract 6r from each side. 12r minus 6r is 6r. Okay. And let's move the number terms to the right by adding 36 to each side. 24 plus 36 is 60. And last step, divide each side by 6. 60 divided by 6 is 10. And as always, you can substitute these solutions into your original equation and show that they do give a true statement. Let's see, in example 4, we're going to solve a problem involving a proportion. If 8 quarts of oil cost $14, how much do 5 quarts of oil cost? And all you've got to do to solve these direct proportions is set up a couple of ratios, putting your units in the corresponding places. Okay, quarts to dollars, quarts to unknown amount in dollars. Okay, and then we're going to set those equal. Are there other ways to set up this proportion? Yep, but this is the most obvious, so I'm going to stick with it, okay? Now we're going to cross multiply and solve for x. 8 times x is equal to 14 times 5. And I've left my units out for now. I'm going to stick them back in here in a minute. Okay, 14 times 5, let's say 50 and 20 or 70. And let's divide each side by 8. 70 divided by 8. Now, since this is an application and we're going to find an amount in terms of dollars, it is okay to use your calculator and divide and write this in decimal form. I'm going to do that. 70 divided by 8. 8.75. Okay, because it makes sense to write this as $8.75. Okay, if we're just solving a plain old equation, I'd prefer for you to leave your answer in a fractional form. But here we're solving for an amount in dollars, so it makes perfect sense to write that in dollars. Okay, and you can check that by substituting in for x and cross multiplying, making sure you get a true statement. Okay, last example for this video, example 5, we're going to solve each percent problem. And I'm going to use the percent equation that says the percent, but I like to think of that as the amount. So I'll kind of use those words interchangeably. Amount equal rate times base. You might see in your textbook a formula that looks like percent equal rate times base. Or you might see an equation that looks like A for amount equal rate times base. And I tend to sort of use that form right there, okay? And the reason that I like it is because it tells me exactly where my percent value needs to go in there as our rate. All right, so what is 15% of 32? Okay, so this unknown amount is our rate, 0.15 times 32. All right, so the is translates as an equal sign. Your percent, we're going to write in its working decimal form by moving that decimal point over 2 places. And the base often follows the word of. So this amount is 15% of 32. And that word of translates as a multiplication symbol. Well, essentially, we're going to multiply 0.15 times 32 to obtain 4.8. That amount is 4.8. 4.8 is 15% of 32. In part B, notice that our sentence looks the same, but we're asked to solve for a different value. Okay, I'm going to translate this. 8 is what percent of 64? Okay, here we're solving for the rate. So divide each side by 64. That rate is 8 divided by 64. And 8 divided by 64 is 0.125. Now this is the working decimal form for that percentage. So I'm going to go ahead and convert this to its percent form because we want to find the actual percent. So let's move that decimal point 2 places to the right. Okay, 12.5% is our answer. And two more here. Part C, Clayton earned 48 points on a 60-point geometry project. Clayton's my son, and that happened. He's out of college now, though, so this is, it's been a while. 48 points on a 60-point geometry project. What percent of the total points did he earn? All right, so I'm going to try to rewrite this in one of our previous two forms and say that 48 is what percent of 60. And if you can rewrite a problem as that sentence, you got it whipped, okay? Because now we go to our mathematical statement. 48 is what percent, solving for R again, okay, of 60. So we're going to divide 48 by 60. And then we're going to convert that to its percentage form. And 48 divided by 60 is 0.8. Okay, so 48 is 80%. Okay, to convert that to its percent form, move your decimal point 2 places to the right. Clayton scored an 80% on that geometry project. All right, lastly, part D. How many points does a student in this class need in order to pass with a C? Well, let's suppose there are 1,000 points available in this course. Okay, in order to pass with a 70%, we need 70% of those points, don't we? So this amount is 70% of 1,000. Okay, in other words, multiply 0.7 times 1,000, and that's just going to move that decimal point 3 places. So in a 1,000 point course, a student would need 700 points in order to pass with a 70%, and that's considered a C or better. All right, students, way to hang in there. We've taken a look at some ratios and proportions and percents in this video. Be sure to keep showing up, working hard, and staying positive.